this next session, we're going to look at editing the tasks that were automatically programmed in the previous exercise, where we assigned the robot to the operations in the process definition. So we'll start off by reviewing the situation. There's our product, vehicle body side assembly. We're going to look at editing the ABB robot program that is responsible for some of the welds in this zone of the product. These are welds 7, 9, 11 and 13. So there's our robot task, a set of instructions that will ultimately be compiled into a program that can be loaded onto a robot in the real world. I'm just going to get rid of some of the extraneous detail around here so that we can see what's going on. So the first step is to go to the robot program, that set of robot tasks, robot task 2, these 4 welds. And we have a little dialog box here that we can use to navigate through the path. You can see down on the product that now we've gone to this, there is a trace of the movements. These are default movements. And if you look carefully, you'll be able to see that the movements, although they go to the correct weld points, don't always do so without causing collisions with parts of either the fixturing or the part itself. So, of particular note, the last 2 welds, where the weld gun appears to move through the part. There's also a problem between the first 2 welds, we'll see in a short while, which is that the curve of the panel causes a collision. Now, to begin with, let's just look at how we can resolve the first 2 problems. We can transform the tag itself, the definition of the orientation of the fastening point. If we rerun the simulation now, we will be able to see that it now orientates on an angle for that. There you go. The next thing, we'll modify the program itself. We'll modify the task for the last weld by just dragging the compass round. This doesn't alter the tag directly, it alters the program, and so we'll just modify that. So 2 ways of accomplishing this, and we can just run through the program again and just confirm that we are getting what we want to get. There you go, and then a 3rd rotation to that location. So that's one way that we can edit a robot program to ensure that we do not get collisions, or to, for example, avoid other robot paths or other pieces of mechanism. So let's zoom in now on those first 2 welds. And I've got collision detection turned on now. And so you'll see a little red mark. You have to look very closely, a little red mark where the lower anvil of the weld gun appears to protrude through the part itself. You see that as a little annulus, a thin red annulus. Now, one mode of running the collision detection is to actually stop the program when a collision is observed. But in these early stages of design, the program would be stopping all the time. So we're just going to allow the graphics to show us with colour when there's a problem. So what we're going to do is we're going to insert a via point, an additional location for the robot to traverse through. And we can do this by adding points before or after tasks in the process. So there we've inserted a via point, and we can just test what's going on here. Okay, so the robot backs away and then moves in. I don't quite like the position of this via point. I think it would be better to move it closer to the second weld. So I'll just move that there and give it a slight rotation as well, okay, to orient the weld gun better to approach the work. I'm now going to put in another via point, an approach point for the first weld. So we'll back the robot off and, whoops, made a mistake there, got the wrong resource. So let's just do that again. Let's click on that location and we'll move that back and insert. And then we'll place another point away from the workpiece, lifted away some kind of clearance point, or a pounce point as it's sometimes called, to jump into the work. And within the program this would be performed in a rapid movement, whereas the close-in work would tend to be done at a slower speed. So we've made these modifications to our program, but there's a lot more that we can do. We can perhaps put in some other via points to move between the second and the third weld, as here, and we can go to the last weld and insert a via point before that location. And also maybe, oops, now there's a mistake. I've accidentally grabbed the compass and manipulated it, and I think that's going to cause me a problem, because I can see from the orientation of the robot and the weld gun that I've actually accidentally introduced a rotation that I didn't want to. But no worry, I can use the compass in a short while to just correct that. There you go, that's an incorrect orientation. So let's just find our way into the location and rotate that around. And there's another axis that I want to rotate around as well. I got confused there, so I can navigate towards that. Okay, and then move that into a slightly better orientation. And when I'm happy with that, I can insert, or modify rather, that location. So I'll modify that. And I can now perhaps think about just checking my program, maybe give it a run through, and possibly also put some additional collision detection on at this stage to make sure that everything is in order. So just doing the final little bits. So I'm going to actually put a few more points in here to back the robot away from the last weld, and to then move it back up towards the pounce point. Get it clear away from the work and the fixturing, so that material handling can come in and move the part on to its next operation, to station 2, when that point is reached. So let's just make those transformations. Let's move that away and insert the via point. And as we're doing this, you'll notice that in the tree, the PPR tree on the left, these additional movements are being added into RobotTask 2. And they're being assigned some default names, which aren't necessarily that easy to interpret. So in a short while we'll go and improve that a little. So let's just check that our RobotTask is working. And in comes the robot, pounces down, approaches, backs off, welds, backs off, welds, backs off, and goes back up towards its starting point. Okay, so let's go back to these robot tasks and let's see if we can tidy up the descriptions a little. So these are all default names that are given by the modelling environment. So we'll call this first operation a pounce. And then we'll have the approach point, which is just away from the work. And there's a lot more that we could do here in terms of defining speeds and accelerations at each of these transition points. I'll leave weld 7, weld 9, weld 11 and weld 13 as they were before. So I'm just going to change the names for the movements that I've added in that aren't related to the actual geometry itself, at least not directly. So I'll just call these all back off points, and then we'll have a return to get back up to the top. Retract. Okay. And we'll see that those have of course changed in the PPR tree, and there they are. So what else can we do? Well, one of the things we can do is we can look at the robot trace the tool center point. So as we run our program now, we'll see a white line appear which is showing the actual movement path. And notice this is different to the yellow line there, which are linear moves, which define the direct line of flight from one point to another. Clearly the robot is a mechanical device, and we have to obey the laws of physics, and also the logic and the calculations, the algorithms that are being performed within the robot controller. So you'll see that many of these paths are actually slightly curved, And that's why it's necessary to do detailed analysis later on. There is also an additional technique and set of tools called realistic robot simulation, which instead of using a generic controller like we've just used here, we can actually apply the real controller logic and dynamics of specified robots. And that allows us to go straight to implementable code that can be downloaded onto a robot in a live environment.